In this video, I'm going to show you how to find the magnitude and direction of a vector, given its components. Let's consider a standard xy axis. We'll draw some vector r that makes an angle theta with the x-axis. This angle is important because when we find the magnitude and direction of the vector, we will talk about its direction in terms of theta above the x-axis. To find the magnitude of the vector, we need to know its components, and since this is a two-dimensional vector we have, the x and y direction will need the two components. It has a y component of 2.5 with units of length. Those can be meters, centimeters, anything that can measure length. And it's going to have an x component of 5. Now that we have those components, we have enough information to find both the magnitude and direction of this vector. First of all, the magnitude. This should remind you of a triangle. In fact, it should remind you of a right triangle to be specific. We can find the hypotenuse length of this triangle, given the length of its other two sides using the Pythagorean theorem. So the length of our vector equals the square root of the sum of the lengths squared, the x side and the y side. If I really want to be precise here, I should call these r's x component squared and r's y component squared. We can go ahead and plug in the information that we have to find the length of the vector now, its magnitude. My x component is 5, my y component is 2.5, and if I square these and add them together, I get 31.25. Go ahead and pause the video to check that I've done this correctly. Before I take the square root, let's think about this intuitively. I know that 6 squared is 36, and I know that 5 squared is 25. So I'd expect the square root of 31.25 to be somewhere in between 5 and 6. Checking this with a calculator, I get 5.6. Which is right between 5 and 6. This is how you find the magnitude of the vector. Now let's work on finding the direction of the vector. All I need to answer here is what is theta, because if I can tell you what theta is, I can say this vector points at a certain angle above the x-axis. Well, remember this is a triangle, and specifically a right triangle. So we can use some basic trig functions to find this. At this point we know the lengths of every single side of the triangle, because we found that the hypotenuse is 5.6. So we could in fact use any trig function here. We could do sine of theta, which equals opposite over hypotenuse, or in this case 2.5 over 5.6. We could use cosine theta, which is adjacent over hypotenuse, or in this case 5 over 5.6. We can use either one of these, or I can even do tangent, which is opposite over adjacent, and in this case that would be 2.5 over 5. Tangent makes the most sense to me here because I was given 2.5 and 5. So if I made some kind of mistake in finding r, that error won't propagate if I find my angle with tangent. The error won't propagate because this was given information. Nonetheless, I can use any of these because I have all of the information for them. I'm going to use tangent because in my mind it is the safest, because I won't be propagating any error if I messed up in finding this r. So let's use tangent to find this. Tangent theta is 2.5 over 5, so I need to take the inverse operation of tangent on both sides of this equation here. I want to take the inverse tangent of the left side, and the other side of my equation I want to take the inverse tangent of 2.5 over 5. Inverse tangents cancel, and now I have inverse tangent 1/2, or 0.5. Using a calculator, I see that the inverse tangent of 0.5 is 0.46 radians. Now if you get a number that is wildly different than 0.46, it likely means your calculator is set in degree mode, so you want to change it to radians and then check my answer. That is how you find the magnitude and direction of a two-dimensional vector.